Hey guys, today we're going to go through lesson 18. So go ahead and open your packet to lesson 18 and let's talk about understanding how to multiply fractions. So the first thing they want us to do is they want us to think it through. What's really going on when we multiply numbers? So let's think about what multiplication is. We know that multiplication is finding the total number of objects in equal groups. Equal is so important because total actually means that we're going to add. But if it's total in equal groups, then we know that it's multiplication. Okay, so remember equal. Think about how you would explain how to multiply 3 by 4 to a third grader. You could draw an area model with 3 rows and 4 columns and then count the boxes. So remember last year you did your arrays. A lot of times you did shapes. So maybe you do like 3 X's and then you knew that this is either 4 groups of 3, 1, 2, 3, 4, or you could also say it as 3 groups of 4, 1, 2, 3. Okay, you can do that either way. So when you multiply 4 times 3, you have 4 groups of 3 or 4 copies of 3 boxes. Okay, so you have 4 copies. So here's 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3. Okay, so you see those groups. Now, how is multiplying fractions like multiplying whole numbers? Well, it really is. When you multiply a fraction like 1/3 by a whole number like 4, you are making 4 copies of 1/3. So here's what they did here. You've got, this is 1/3. Okay, so what if I did 1/3, 1/3, 1/3, and 1/3? Okay, now if I said to you, okay, what is the total? Well, you could say, well, I'm going to add 1/3 plus 1/3 plus 1/3 plus 1/3. That's going to be the slow way. We've talked about that before. That yes, you can always add, but if you're adding the same thing over and over and over again, it doesn't make sense to add because your numbers are going to get too big. So we're going to multiply. So here's what they did. I'm sure you can see it better on yours, but I'm just going to shade these in quick so that there's a very distinct difference. Okay, so we have 1/3, not worried about this yet, 1/3 4 times. 1, 2, 3, 4. Think about those pieces, okay? Now, when you look at this, I don't want you to think, well, wait a minute, Mrs. Reed, this is 1, 2, 3, 4 twelfths. No, because all of these pieces together do not make a whole. This is one whole piece, this is one whole piece, this is one whole piece, and this is one whole piece. So we're talking about 4 different whole size pieces, okay? Or I should just say wholes, 4 wholes. This is a whole, this is a whole, this is a whole, this is a whole. This is my piece. So this is a 1/3 size piece, and I've got 4 of them. So all they did here was they took these 4 whole size pieces and then they put them together. Okay. Now we've talked about this before. Let me go to my scrap sheet. We've talked about back when we first started fractions. Get this on my clipboard here. We talked about fractions that look like this. And we talked about how this is one whole, and we talked about how this is one whole. So when we first started fractions, and I showed you something like this, you all said, oh, Mrs. Reed, that's 4/6. 1, 2, 3, 4 out of 6 total. But I said, wait a minute, you've got to look at the gap here. This is one whole piece, and this is one whole piece. Okay, so what we did was we looked at, okay, well, we're working with thirds. Do you remember we talked about what size piece are we working with? You figure out your size piece you're working with by counting the number of pieces in one whole. So we're working with thirds here. Well, it just so happens, I guess I got the idea from the last problem. So we're working with thirds. So thirds is going to be my denominator. The top is the pieces, the bottom is the size. How many pieces are shaded? 1, 2, 3, 4. Okay? So when we're looking at this problem, all it is they just rearranged it a little bit differently. But the fact still remains the same. We took 1/3, 1/3, 1/3, 1/3, 1/3, and we did it 4 times. Okay? Now, when we set that up, actually I guess it's right here. When you set that up, it's going to look something like this. 4 times 1/3. 4 copies of 1/3. So when we start to look at this, now for this year, you're only going to multiply by whole numbers. I believe either next year, definitely 6th grade, you're going to multiply fractions by fractions. But this year, we are only multiplying by whole numbers. So it's kind of nice. It's a nice, easy transition because when you look at this, you're going to multiply 4 times 1 because that's the number of pieces. This is how many pieces I have. And this is my size. Okay? So what we're going to do is we're going to talk about, wait, what did I just do there? I put it over 1. Why? We'll talk about that. Okay? So let's move on to the next page. They're going to still have us looking at the same model. Okay? 4 times 1/3, we know there's 4 pieces and they're 1/3 size. This is a model to show it. It says, notice the denominator of the fraction is 1/3, the denominator of the product is 4/3, are not the same. The denominator tells the size of the equal parts in one whole. So the fraction and the product both have the same equal size parts. They both have thirds. Okay? Now it says, suppose you have 2 groups of 4/3 S. Or I'm sorry, 4/3. I guess it's got the S there. To find the total number of 4/3 in 2 copies, you can multiply 4/3 by 2. So here, basically what they're wanting you to do is you've got 4/3 times 2. Now, I like to put my whole number in the front just because it works best for my brain. And we're going to keep it on top. The whole number is going to stay on top. Okay? The way that I think about this, I always put my 2 over 1 so it reminds me I'm not going to multiply. I'm not going to come down to the denominator. You've got to keep your whole number on top. Okay? Because do you agree that 2 over 1 is the exact same thing as 2? 4 over 1, exact same thing as 4. 5 over 1 is 5. 6 over 1 is 6. We've talked about how anytime you put something over 1, it's just the number that you started with. So when we put our whole number over 1, it reminds us that the numbers that are on top, they stay on top. The numbers that are on the bottom, they stay on the bottom. I've seen so many kids, don't do this, who will say, oh, okay, here's my whole number. 2 times 4 is 8. I like it. 2 times 3 is 6. No, don't do that. Put your 1 underneath your 2 to help you remember this whole number has to stay on the top. Because if you did that, if you did this and you did 2 times 4 and 2 times 3, you've actually changed your fraction. You've changed your fraction. Look at that. We started with 2 over 1, which is the same as 2. And if you do this and multiply the top and the bottom, you've changed your whole fraction to 2 over 2. No, we can't do that. Okay? So, keep your whole number in the numerator or in the top. Put it over 1 because it's the same thing to remind you not to do the denominator. So in that problem, they wanted you to do 2 times 4, which equals 8. 1 times 3 is going to give me 3. So all this means is if I have 4 thirds, third size pieces, third size pieces, not the most beautiful creation I've ever made, but it works. All right, so if I take 4 thirds, 1, 2, 3, 4, 1, 2, 3, 4. Okay, and I put them together. I have 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces. What's the size? They're thirds. Okay, I didn't change the size of the piece. You watch me draw them. You watch me shade them. I didn't change the size of the piece, so I have to keep my size as thirds. Okay, so we've got 8 thirds on there. So I'm not a huge fan of how they did that here. What they did was they used the distributive property, which I don't think is necessary here. If we just look at the 2 times the 4 thirds, and we know, so this is one of those Mrs. Reed's way. If you just put that 2 over 1, you just got yourself to the same answer. So that's what I would recommend. So down at the bottom it says 5 times 1/3 means, well, what does it mean? It means that you have 1/3, get this on here, you have 1/3 5 times. Kind of gives you the answer right in the problem. So I'm going to give just a little bit, 1/3 and 1/3 and 1/3 and 1/3 and 1/3. Oh, gracious. So I have 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 is the same as or equal to 5 times 1/3. That's the same thing, guys. It's just representing it 2 different ways. Here's addition. Here's multiplication. Okay, we know this is the same. All right, so let's look at what's next. All right, it says fill in the blanks to find 5 times 3/4 using repeated addition. Well, if we know we have 3/4 5 times, there's 1 time, 2 times, 3 times, 4 times, 5 times. So what is our answer going to be when we add? Add the pieces, not the size. 3, 6, 9, 12, 15. Never touch the size. Fourths. So there's 15 fourths. So now if I fill in my model, shade the model, I can do it as 3/4. So they've got it all here for me. It's already separated into fourths. There's fourths, 4/4, 4/4, 4/4, okay? We want 3/4, so we're going to shade in 3 of them. Okay, now let's count. How many do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, and what size are they? They're fourths. Okay, same thing. All right, now they said fill in the blanks to find the expression 2 times 5, 6. Well, we've got 5, 6. How many times? 2. So 5, 6 and 5, 6 is the same as 2 times 5, 6, or 2 times I see 5 sixths. Add your pieces, not your size. 10 sixths. If I do my picture, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10, and they're sixth size pieces. Now, hopefully some of you are saying, Mrs. Reed, look at those fractions. There's something wrong with them. Absolutely. Hopefully you had a red flag that said improper. I don't think that they really care right now because we're multiplying, but you know what? We can do it, so we're going to do it. How many times can I count by 4 until I get close to 15 without going over. Or how many times does 4 go into 15? 4, 8, 12, 16. Oh, 16 is too high. So 3 times. 3 times is going to get me to 12. So 13, 14, 15. So I have 3 left over. And I'm working with fourths. This would be our proper answer. Let's come down to 10/6. How many times can I count by 6 until I get to 10 without going over? Or how many times does 6 go into 10? 6, 12. Oh, that's already over. So it only goes in 1 time. If I do it 1 time, that's going to give me 6. How do I get up to 10? I need 4 more pieces. And my size is sixths. Okay, so there's my 2 proper answers. Always keep them proper. All right, let's see. Now they want us to fill in the blanks to show other ways to write the same product as 5 times 3/4. Well, here you have 1/4. Okay, I'm not a really big fan of how they're doing this, but if we look at the 5 times 3/4 that we have up here, how many times do we have the 1/4 piece? Look over here. How many times do we have that 1/4 piece? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what they want us to see is we have the 1/4 piece 15 times. So 15 times 1/4. Okay. Or it says that you can do 3 times, well, how many pieces, or what is the end result that we want? We want this to equal 15/4. So how do we get from 3 to 15? This number on top would be 5. I'm not a real big fan of what they're showing here. I guess this would be the same thing. 10 times we see what size? We see 1/6. If we want the end result to be 10/6, how do I get from, what whole number do I need here to multiply by 2 to get to 10? I need 5. Again, I don't like this. I'm not really sure why they did that to you. So let's stick with this. Let's just understand that we need 15 1/4 size pieces to equal 15/4. And we need 10 1/6 size pieces to equal 10/6. Okay? All right, draw a model to show 4 times 2/3. All right, so 4 times I see 2/3. All right, we're good, right? There's 2/3. Hopefully you said no. We need 4 times. All right. So 4 times I see 2/3. All right. Well, what did I get? 1, 2, 3, 4, 5, 6, 7, 8. 8. And what size piece am I working with? I'm working with thirds. Would have been the exact same thing I got if I just put my whole number over 1 and multiplied. Okay. Let's look at this one. Draw a model to show 3 times 2/4. Okay, so 3 times I see 2/4. I should make my boxes a little bigger. All right, so here's 2/4. 1 time, 2 times, 3 times. What did I get? 1, 2, 3, 4, 5, 6. What size am I working with? Fourths. Would have been the exact same thing if I had just thrown my whole number over 1, so I kept it the same, equal value, and then multiplied across. All right. We got one more page here. All right, it says, look at your model for problem 6. Draw another model that shows 8 and 1/3, or 8 times 1/3, sorry. Well, what was problem 6? Problem 6, okay, so problem 6 was the 4 times 2/3. So we did 4 times 2/3 there, and we got, stick that over 1, go right across, 8/3. Okay. This is the same thing, guys. 8 times 1/3, put that over 1. So how are the two models different? Let's do it on scrap paper. All right, so here we go. 4 times 2/3. So 4 times, I see 2/3. Okay, and then they wanted 8 times 1/3. Going to use those blue lines there to kind of speed this up. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. Woo! And then there's one of them. Oh, and I kind of like how I accidentally set this up. This is perfect. All right, so let's look at it. Is it the same number of pieces shaded? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Is it the same size? Thirds, 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 thirds. Thirds, 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 thirds. Yes. What's the difference? All we did was we took these 4 and put them together with these 4. You see that? So the top is all in there. So there's the top. These pieces all were down here. That's all we did, was we just moved them around a little bit. So how are the two models different? In 4 times 2/3, 2 of the pieces in each fraction are shaded. In 8 times 1/3, 1 of each fraction are shaded. So it says, what is the total number of thirds shaded in each model? Well, both of them have 8. Now you're going to look at your problem for problem 7. How many fourths are shaded in all? Well, we already did it. We know 6. Think of a different model with a total of 6 fourths shaded. Fill in the blank to write what is needed. So how many fourth size pieces do we need to get 6 fourths? How many pieces, for 1/4 size pieces, do I need to equal 6 fourths? Well, I'm going to need 6 of them, right? All right, so try it another way. You know I'm not a huge fan of number lines. They get so messy so quickly, but we'll just kind of tough it through this one just in case it works for your brain. Doesn't really work for mine. So it says fill in the blanks in the number line to show 4 times 3/5. So we've got 3/5, 6/5, 9/5, 12/5. Okay, all they're doing is counting by threes. Same exact thing as putting your whole number over 1 and multiplying straight across. Same thing. Down here, we're starting at 2/10, and we're doing it 6 times. So, like, see here, we jumped by 3 4 times. 1, 2, well, I'm sorry, 3 times. So 4 groups, 1, 2, 3, 4. So here we're going to do it, 4/10, 6/10, 8/10, 10/10, 12/10. Oops. Oh goodness, never change that. 12/10. So we did it 6 times. So here we did it 4 times. Here we did it 6 times. 1, 2, 3, 4, 5, 6. So our final result is 12/10. However, Mrs. Reed's way, throw that 6 over a 1 because then we don't change what number it is and get 12/10. Okay? I hope this helps for lesson 18. We'll be back for lesson 19. Bye, guys.